And welcome back, everyone. IT Arena Business Track is back on track. We're moving on to the next speech we will have today. We will be talking about the agents of change, how to define growth in a world that likely will remain unpredictable, which is pretty cool for me because this year and the last year we heard a lot of stories about the success of Zoom, Microsoft Teams, other messengers that were helping people to communicate in this remote world. But what will happen the next year? What to expect? What are the critical things to know? What are the critical things to do right now? So we will be prepared for the next year for all the unpredictable changes. And today about this we will have Walid Nam, Capgemini Engineering Executive Vice President, Chief Research and Innovation Officer, to slightly raise the curtain on this issue in this case. Hi Walid, and welcome to Lviv.
Thank you so much, it's great to be here.
How do you feel in Lviv? Is this your first time in Ukraine?
It's my first time, I love it. I came here yesterday, I think it's yesterday, a little bit jet lagged, but it's a beautiful city, wonderful people.
It is, and what is the best thing that we have sunny weather, because in Lviv is like little London, you know, like always raining, almost all of the time. So I'm happy that you're in Lviv and you see the sunshine here.
I used to live in London, so that's nothing.
Once
you live in London, it's it's uphill from there, weather-wise.
Okay, got it. So guys, if you will have any questions to the session, please leave them in the chat in the IT Arena app, and I will read them out at the end at the Q&A session. Walid, stage is yours.
Thanks a lot. So yeah, great to be here again. My name is Walid Negam, and I just want to be a little bit provocative today. I changed the title and presentation, a software eclipse, because I think that's it's going to be a metaphor for defending growth, especially in the sectors that I'm going to be covering today, which is industrial sectors, automotive, aerospace, and others. But real first, what's an eclipse? Eclipse is when one celestial body is overshadowed by another, and it's sort of a change in perception, right? You're in darkness, for example. And it serves as a metaphor for today's presentation because we know that software is dominating, right? Software dominates a lot of the value creation today. And if you look at the valuations of startups and big companies alike, it resides in software, right? In the fact that their software plays. In fact, over the last 8 months or so, the number of billion-dollar companies, unicorns, went from 400 to about 700. So significant value creation in software. However, in the coming decades, we'll also see trillions of dollars invested in these new catalysts of economic growth that go a little bit beyond software, right? If you think about energy and energy transition, you talk about hydrogen fuel cells, aviation. If you look at even space, right? There's about 155 launch vehicles just up and running today to bring up these constellations, right? These low Earth orbit constellations. And then finally, in the automotive industry, I mean, we don't buy cars, right? We buy the in-car experience. So I think the idea that software is being eclipsed by hardware is kind of the theme of the presentation today. And what are the implications for product developers when that starts to happen? Maybe it's not an eclipse of software, but maybe a partial eclipse. So get started here. There's 3 videos going to play, and I just wanted to give you an idea of what we mean by the penetration of software is more than we think in the physical world, right? So each of these videos are meant to show that software does run the show, right? So if you're a software developer, the hardware seems to be behind the scenes, but you know, make no mistake, there is hardware here. In the first video, it's by General Motors Cruise brand, right? And it's steering, accelerating, and navigating on its own. It's stopping at the right time. 95 or 90% of all of the innovations in automotive will be software. It's not going to be mechanics anymore. In the second video, if you saw it play, you could see the design team at Airbus showing off what's basically an entirely new urban air mobility solution. Right? This is a particular aircraft that takes off vertically and lands. It needs energy, it needs batteries, and software is managing the batteries. Software is managing the autonomous flight when it goes vertical and landing. And in the last video, you'll see a swarm of robots. If you probably saw it whiz by in an automated warehouse. And these robots are moving at 4 meters per second and with a clearance of about 5 millimeters. That's all, the magic is in software, right? So it's obvious that software is crucial to these solutions. And just to get a little bit deeper in and trying to transition between software and hardware, as you could see here, the automobile is moving from metal to code. And if you look a little bit closer at the automotive industry, they're speaking about themselves as software players, right? So the innovation inertia in hardware is being replaced by software velocity and how you can make this vehicle programmable. Instead of having a hardware chassis, you have a software chassis, right? And you're loading up over-the-air functionality. What is that? Lane departure warnings, I don't know, collision avoidance signals, driver monitoring. It's just basically you're buying the software in the vehicle. And if you're a software developer watching this, you're very familiar with the image on the right? This is a cloud-native architecture. And OEMs are not going to be looking at a monolithic picture on the left. They're going to be looking at microservices, software delivered on the fly, and they're actually hiring software engineers at scale, right? GM, I think, is hiring 5,000 software and digital designers. VW made a similar move. But here's where I think the catch starts to happen is that there's critical safety requirements in automotive. There are real-time performance challenges in automotive, and there's silicon in automotive, right? So silicon is definitely a big part of complex products. Beyond automotive, though, software is a defining cost in every end solution. This is just a little bit perspective on what the R&D spend. I'll share a little bit of where this number comes into play in terms of Capgemini engineering. But if you look at all the big spenders, if you add them all up, and the little spenders, it's about $1.9 trillion on research and development and engineering. And most of that spend is going to be moving into the blue bar, right? The blue bar meaning a digital capability, data science, the connectivity and software and embedded software. So the shift is clearly in software. Okay, now I've said software dominates. Here's the however, right? The however is that we are in a physical world, right? And if the provocation is that software is going to be eclipsed, the provocation is that it's going to be eclipsed by hardware. And I think that's an exaggeration. There's going to be a role for hardware to play in this physical world, and that's where a lot of these opportunities are going to be, right? In automotive, in life sciences, in aerospace. And if you think of the things that are out there, the chart at the top right is by a company called ARM. Anything that has a battery, anything that runs on electricity probably has an ARM-based chipset inside it. And there's 190 billion of these things running around. Anything from sensors in your smart home to factories and facilities in the automotive sector, a significant number of electronic control units. Just last week, if you're watching Amazon's product launch, I think it's undeniable that they're getting into the physical domain as well. They had a surveillance robot, something for the kids. But there's semiconductors and electronics in these products. And the question is, what are the implications for product developers when you have to deal with this hardware, right? There's going to be a software component, but in order to capture this fresh opportunity, right, in the industrial sector, in aerospace, in life sciences, the software developer, the product developer has to cross over. They have to cross over into the hardware world, and then vice versa. The hardware folks have to cross over into the software. I didn't talk about Capgemini. I just wanted to touch a little bit about Capgemini. We're a recognizable name in the IT services space, about approaching $20 billion in revenue, operating globally. Of course, one of our areas of focus is engineering. We have about 52,000 engineers. What does that mean? We have 12,000 people that just dedicated to aerospace. You can look up our certificate with EASA, which is the European Space Agency. We're responsible for design and development in the aviation sector. And we have a similar large number of folks in automotive and also in life sciences. So when it comes to building complex physical products, Capgemini Engineering has a pretty good track record, pretty good resume. So this talent squeeze, again, as business leaders or as technology leaders, it's important to recognize that there is a talent squeeze happening when you think about complex products. I mean, it's easy to say everything, like when Facebook went down, everybody went nuts, right? Facebook's down, I can't reach anybody because I don't have Facebook. But what happens when you put some code in an automobile, in a car, and you just haven't done it right? You get into a collision, the sensor is miscalibrated. I think these are the types of things that a software developer and a product is going to have to get more versed in. And there has to be a little bit of a different approach than just pure agile, right? So pure agile says it's about continuous delivery, it's about code, velocity, but when you have a hardware product that's a little bit more complex, you have to take into consideration safety criticality, real-time performance. So that the language barrier between the software world and the hardware has to be bridged. And that diagram in the middle just gives you an idea of the big difference. There's a literal V model when you think of a complex product. You have to sort out all the requirements first, and then you have to certify the product in front of regulators, right? You can't just release a plane into the, you can't just fly a plane overnight. In the software world, I mean, if you look at Spotify, 6 builds a day, I think is what it takes. Yeah, it has about 6 production deployments a week. You can't do that in the automotive realm. So both of those worlds have to somehow come together. And this sort of builds into the implications. If you're a product developer, if you run a product development team, if you want to take advantage of some of these incredible opportunities, I think the implications are 3 at least, right? First, software engineers have to carefully architect alongside hardware teams, right? If you want to capitalize on clean energy, if you want to capitalize on automotive sector transition to the software-defined car, there has to be the monetization path is through trustworthy software-defined systems, right? So it's a very different paradigm. I think second, that V model of hard requirements, then certification in front of regulators has to be loosened up a little bit without sacrificing safety criticality. And you can do that in virtual environments, right? So beyond the physical. And finally, product developers, the planet matters. Product development teams have to consider reducing waste, energy efficiency. You have to go beyond the product and beyond the end of life of the product. So let me just step into one of each of those. Hopefully we have enough time here. The first example is software-defined car, and I just wanted to show you what it means for hardware to cross over into software and software to cross over into hardware. The video at the top is a computer algorithm. It's detecting pedestrians, it's detecting cars, and it's sharing that information so we can avoid a collision. Okay, that's easy. We do that every day. But if you look at the second image, if you take a close look, the first frame has a red traffic light turned on. The second frame has no lights on, and the third frame has a red traffic light turned on again. And the reason is the camera is picking up the frames, right? Whereas the LED is flickering at 50 hertz per second. So it's unnoticeable to us, but the camera is picking it up. Now that becomes a problem. If you're a software developer, that's a problem, right? You can cause a car accident. So the flickering can pose a significant challenge in perception. So what are you going to do about that? Well, the first thing you have to dumb down, this is a superhuman algorithm, right? In one sense, right? So you have to dumb down the image processing a little bit. And you may want to take the code and then isolate that in a certain part of the system so it's protected, right? So you don't interfere with other parts of the code. These types of decisions actually have started to happen. If you're a developer in the gaming environment, you know about NVIDIA's stack. You know really well how it works. But more and more software developers are needed in these industries. Otherwise, we're not going to go anywhere, literally. The second example I wanted to give is in healthcare. Another example where hardware and software are crossing over into each other and the implications for product development teams, but also companies who want to make money. The Apple Watch is what's called it's a medical device, and it informs on vital health signs, and it actually helps diagnose. Companies in this sector, they're not only life sciences companies, but also high-tech companies. They're releasing product candidates. They're not just releasing drugs anymore. And again, if you're a software developer, if you're a product maker, and you want to get into this space, you actually make a decision. What category of product am I going to make? Am I going to be a type 1, type 2, 3, or 4, or 5? These are all classified according to the intervention that happens in healthcare. What's the examples of these medical devices? Glucose monitors, pacemakers, right? These are the types of devices. They all need software. And one of the interesting ones that's where software developers are participating significantly in is digital therapies. The image on the left is an example of someone who may have lazy eye. It's a condition that affects only one eye, and it can't see as clearly because it's weak. But they designed a software game. I think Ubisoft designed this, right? So it's a software shop, and it was designed as what's called a dioptic display. So instead of having a patch, you walk around with a patch of it, it's exercising the weak eye and strengthening the weak. And that's an algorithm, right? The problem with that is you can't have a glitch with that algorithm. You could really mess up the patient. And so software developers have to understand the sector-specific requirements. What is a robust life cycle to evaluate the performance of this algorithm, right? You can't just release it in the wild like a TikTok app, right? It's just not going to work. And while there's clinical chemistry and bioinformatics involved, there's going to also be a software development life cycle. So a product launch, when hardware and software cross over into each other, is very, very different. The next section I wanted to cover in terms of, if you're a company who wants to take advantage of some massive opportunities, is the way you build something often matters as much as what you're building in the first place. This is an example of a vertical takeoff and landing vehicle. If you have a good idea in aerospace, you have to certify it, right? And the only way to certify it is to get what's called an airworthiness certificate. And the only way to get an airworthiness certificate is to be able to prove that the plane can actually fly under extreme conditions. And a lot of digital modeling is happening here, right? The digital modeling is something that the hardware world is learning from the software environment, right? With the cloud and DevOps and Agile. And on the left-hand side that's playing around is actually a physical model that actually has to be built eventually for ground testing and for flight testing, but most of the energy is actually being spent in creating digital threads and digital and virtual environments so you can study the propeller and you can study the blade design. You can make decisions on the propulsive systems. You can understand the pressure profile of the winglet and make decisions. These are all disciplines that are coming from the software realm, right? How do you do that in simulation? And I think there's going to be a lot of collaboration between the software world and the hardware worlds. Another example where the software world and the hardware world are collaborating is, we typically need machine learning experts to put together a predictive model. You have something in the wild and you want to predict its failure. In this case, this is a fuel cell. We talked about clean energy. Right? Clean energy, you need chemists and you need folks who understand fuel cells, but you need software engineers who can create predictive models to make sure that these parts don't fail. In this case, you can see with the red dots that the compressor for this particular fuel cell, and it's a complex system, right, is failing under certain conditions. And a predictive model was developed by the machine learning experts. When does the crossover happen? Well, that has to be shared with the design team, right? Why am I going to live with a fuel cell that fails under certain conditions? So how do you expedite the exploration of new design options in the hardware world? Well, you need the data scientists to feed these types of results back into the design team, right? So complex product that needs both software and hardware. The last example, as I wanted to show you, is when you make decisions about a product, you typically think about features, risk, schedule, performance. But now the environment is non-negotiable, and companies are realizing that you have to look at other factors like reuse and recycling and energy efficiency. This is a very specific example of a solution that was developed for the telecommunications sector. I'll explain. If you have a mobile phone, every time you make a phone call, the cell tower is checking if you have enough bandwidth. With millions of phones out there, hundreds of millions of phones, each cell tower is making a decision, do you need enough bandwidth? Most of the times, they're giving you more than you need. Although it feels that we get less than we need when we have a video that's shaky. But most of the times, if you look at the top image, the green is an attempt by the cell tower to match the bandwidth that you need, which is yellow. That's the best way to think about it. It's not matching very well. So it's either under provisioning or over provisioning. And on the bottom slide, you'll see the green is matching a little bit better, the yellow, right? So here we designed an algorithm that allows the cell tower to efficiently allocate spectrum to mobile phones. Now, if you imagine with hundreds of millions of phones, that's energy savings. The developer and the development team didn't need to think about that, right? But by doing so, we can help solve some interesting problems and challenges. Another example where there's a big crossover between software and hardware is in optimization, right? We have machine learning experts and folks that understand computational optimizations. On the left-hand side, right, is a layout of a chip. And in all modern electronics, you have a transistor. It's a switch that has billions of transitions in it. One of the big challenges is how do you place all these chips on the silicon? Typically, we look for price, performance, the size, but also energy, right? Energy consumption. And you can use AI to actually position all the gates, all the different transitions in a way that aids in energy efficiency. The innovations, the thought process, the creativity is coming from the software world. But we need it in hardware, right? We need it in the hardware realm. And I think that crossover is going to be a massive area of opportunity. On the right-hand side, a little bit more of a manufacturing example. If you look carefully at that image as a crack, this is sheet metal that's going to be used for a car, to manufacture a car. And you use computer vision today in order to detect the crack. And if you detect it early enough, you can fix it and it doesn't become throwaway further down the assembly line, right? computer vision works, but if you use quantum, which is not a toy anymore, you can use quantum sensing, right, which is, you know, a whole other realm. And actually, instead of infrared, there are other quantum mechanics data that can be used in order to detect that crack at a much higher fidelity. Yeah, who's pioneering quantum and quantum machine learning? There's certainly different layers. There's actually the sensing, and then there's the you know, the hardware, the quantum computers. But it's that creativity from the software realm that we need to bring over into the industrial internet, into intelligent industry. I think that poses a massive opportunity. I wanted to end with this example because it was kind of cool, where we had a multidisciplinary team of software engineers, of mechanical engineers. We ended up building what's a catamaran. This Capgemini catamaran is powered by clean energy, and it's optimized. And it's all multidisciplinary. You need the digital skills to develop the human-machine interface for this. You need to be able to have a boat that actually circuits this particular race at the right time. This was a hydrogen fuel cell, so you needed folks to understand energy. And they all came together to build this. And if you think about the massive opportunities I listed out earlier, you know, it's basically there's a physical component to a lot of these significant economic transitions and catalysts. So I hope that, you know, we get software engineers who participate in intelligent industry. Hope we build products that are good for the planet. And I think there's going to be a lot of interesting talent needs that are going to come up in the coming decades, in the coming years, of course. So these are some of the examples of Capgemini's work. Just wanted to kind of leave it up there for the audience. And thank you very much.
Thanks, Walid. That was really amazing for me, because I have a lot of questions and I don't know how to structure them properly. Because of what? Like, let's start with this. Do you think that hardware is dead, or hardware reached its limits where it can go, where it can improve? Because what you're saying that the software is just moving forward with different opportunities seizing with the existing hardware. So more software, less hardware. The car is not changing pretty much, like the same transmission, the same wheels, nothing really changing much, even the designs, but the software is changing a lot. So is the hardware like not dead, but like is on the top and you cannot improve it anymore? Or is there like so many opportunities for any kind of software development, software innovations that you may push and push and push and push this?
Personally, I definitely think that more of the innovations are happening in software. This is clear in automotive, in every area. But the point is you can't get around understanding the hardware that sits underneath, right? Software runs in silicon, software runs on processors, software runs on boards and systems. At the end of the day, you need an industrial design. So I think software definitely is where the predominant cost structure is going to be. It's where the value is going to be mainly created. But you know, when you look at the example I shared, a fuel cell, you need chemists. You know, you need aluminium. You need
even need engineers to properly shape it.
That's right. So I'm on the side that, you know, that's why I say a partial eclipse of software, you know, meaning software is dominant, but maybe there's, you know, let's not forget that we live in a very physical world. It's a very exciting world. And a lot of the things we have to solve for the planet, they have a physical manifestation, right? Rails, trains, planes, cars, you know, it's inevitable.
But they're not improving anymore.
So software is going to help improve them.
Yeah.
Software is helping improve that. And if you ask the question about what part of the hardware is helping, well, the silicon chips are becoming more energy efficient themselves, right? We talked about that example. And you need some of the chemists and the engineers to solve for propulsion, for example, new forms of propulsion, or the battery that was designed for these electric cars. You need engineers to design for that. So, you know, sitting in front of a software engineer, they probably say software rules the world, right? But you know, I think there's definitely a significant role for hardware to play in value creation.
I do hope that someone will be left to work on the hardware, because a lot of people are doing software and not so much people working with the hardware at all. To be honest and frankly with you, for the next year, your predictions in this unpredictability, so where should businesses focus right now? So developing software, moving in that direction, trying to find improvements. We talked about the algorithms that are pretty hard to do for the self-driving cars, specifically with the lighters, yeah? So there is a lot of these tiny details So where you will suggest to move to another businesses and other companies who are working with the software?
So the question is, depends on the audience. And for me, a lot of my audience is industrial sector, big GDP, right? We talked about those industries. And when we have conversations with these clients, they are all into software. And so it's how do we work with these industry sectors to solve their problems and their challenges. I say that's a significant amount of opportunity. And software is a big part of the answer to them, both in recurring revenue, right? If you have a car, or, even if you have a plane and you want infotainment, it's a recurring revenue stream. In the industrial sector, they're looking for recurring revenue streams in maintenance. So I think software in industrial sectors is extremely important, and it's a very important trend, and it's accelerating. That's where we see a lot of play. That's where we see a lot of talent demand. That's why we're encouraging people to join and work with Capgemini and the ecosystem to solve some of these major challenges.
That's amazing, guys. Please look at this slide, find Google Capgemini in Google, and really try to find what they're doing right now. What do you think also about this trend in making software that works with eco-friendly devices? You know, this all eco-friendly generation that we are in living, all of the devices trying to be more eco-friendly, even the electrical vehicles, you know, like everything to save the environment. Can software somehow help to save the environment too? So we were speaking about a specific software for self-driving cars, for drones, for anything that doesn't work on fuel. We spoke about the hydrogen fuel that will come. It's not so damaging to the nature as we know of it, but where else do you see the software may go in this eco-friendly environment? What are the areas where we can push and help the world get better?
I mean, for me, without kind of reaching too much, I think the point is we need software engineers or software talent, because they are very entrepreneurial and they think outside the box, right? They're very creative. Not that in the hardware world they're not creative, but they're restricted by regulations, right? They're restricted. Their thought process is definitely around safety criticality and performance. So I think the creativity in answering your question happens from the entrepreneurs in the software world, right? And that example, by the way, for the radio cell tower energy, that was from the software team talking with the telecommunications team and trying to find out what's a creative solution for power efficiency in 5G. So I think it's the idea of how we can cross over between hardware and software, and how teams can collaborate more together.
So collaboration and trying to break the regulations or to change the regulations, which are not like stopping this process in general.
Yeah,
right?
I would say bend but not break, because the reality is regulations are there for our safety, and some of them are, have been there for decades for a reason. But I think there's bend but not break.
There is an area for improvement in there and for bending.
Yes, right.
Thanks again for the great presentation, guys. You will see the recording of this session in a few weeks. The team will prepare, so you may double check the presentation that we saw today. Thanks, Walid, for being with us today. Thanks for being here in Lviv. We welcome you to go back to your home, tell your friends that Lviv is great, and come back with a lot of friends here, so we may celebrate. Okay, guys, it was Walid Nam, Executive Vice President and Chief Research Engineer at Capgemini Engineering. Thanks a lot again for being here with us today. And guys, the next speech we will have at Business Track will be the keynote speech of the conference. We will have May Musk here, not in the studio, but with us on the stream. So stay tuned and see ya. Bye-bye.